Shri Rajalakshmi Prakashan published. A textbook on fundamentals of agronomy 1. Authors: Dr. D. N. Jagtap, Dr. P. B. Pawar, Dr. U. V. Mahadkar. Chapter 2. Tillage, its definition, objects of tillage, types of tillage, tillage implements and factors affecting tillage, effect of tillage on soil and crop growth. Tillage operations in various forms have been practiced from the very inception of growing plants. Primitive man used tools to disturb the soils for placing seeds. The word tillage is derived from the Anglo-Saxon words tillion and teolion, meaning to plough and prepare soil for seed to sow, to cultivate and to raise crops. Jethro Tull, who is considered as father of tillage, suggested that thorough ploughing is necessary so as to make the soil into fine particles. Tillage is the oldest and most fundamental activity of man in the production of crops. It refers to mechanical manipulation of the soil that are used to provide necessary soil conditions favorable for the growth of crops. These operations include ploughing, harrowing and mechanical destruction of weeds and soil crust. Mechanical manipulation of the soil with tools and implements so as to create favorable soil conditions for better seed germination and subsequent growth of crops is known as tillage. Objectives of tillage. Tillage is done to prepare ideal seed bed favorable for seed germination, growth and establishment, to loosen the soil for easy root penetration and proliferation, to remove other sprouting materials in the soil, to control weeds, to certain extent to control pests and diseases which harbor in the soil, to improve soil physical conditions, to ensure adequate aeration in the root zone which in turn favor for microbial and biochemical activities, to modify soil temperature, to break hard soil pans and to improve drainage facility, to incorporate crop residues and organic matter left over, to conserve soil by minimizing the soil erosion, to conserve the soil moisture, to harvest efficiently the effective rainwater, to assure the through mixing of manures, fertilizers and pesticides in the soil, to facilitate water infiltration and thus increasing the water holding capacity of the soil, to level the field for efficient water management. To achieve these objectives, the soil is disturbed, opened up and turned over. Types of tillage. Tillage operations may be grouped into 1. On-season tillage, 2. Off-season tillage. Type 1. On-season tillage. It is done during the cropping season, June to July or September to October. Tillage operations that are done for raising crops in the same season or at the onset of the crop season are known as on-season tillage. They may be preparatory cultivation and after cultivation. Point A. Preparatory tillage. This refers to tillage operations that are done to prepare the field for raising crops. It consists of deep opening and loosening of the soil to bring about a desirable tilth as well as to incorporate or uproot weeds and crop stubble when the soil is in a workable condition. Types of preparatory tillage. Type A. Primary tillage. Type B. Secondary tillage. Type A. Primary tillage. The tillage operation that is done after the harvest of crop to bring the land under cultivation is known as primary tillage or ploughing. It is normally the deepest operation performed during the period between two crops. Depth may range from 10 to 30 centimeters. It includes ploughing to cut and invert the soil for further operation. It consists of deep opening and loosening the soil to bring out the desirable tilth. The main objective is to control weeds, to incorporate crop stubbles and to restore soil structure. Ploughing is the opening of compact soil with the help of different ploughs. Country plough, mold board plough, Bose plough, tractor and power tiller drawing implements are used for primary tillage. Type B. Secondary tillage. The tillage operations that are performed on the soil after primary tillage to bring a good soil tilth are known as secondary tillage. In this operation, the soil is stirred and conditioned by breaking the clods and crust, closing of cracks and crevices that form on drying. Secondary tillage consists of lighter or finer operation which is done to clean the soil, break the clods and incorporate the manure and fertilizers. Incorporation of manures and fertilizers, leveling, mulching, forming ridges and furrows are the main objectives. It includes cultivating, harrowing, pulverizing, raking, leveling and ridging operations. Harrowing and planking is done to serve those purposes. Planking is done to crush the hard clods, level the soil surface, and to compact the soil lightly. Harrows, cultivators, gantakas and spade are used for secondary tillage. Type C. Layout of seed bed. This is also one of the components of preparatory tillage. Leveling board, buck scrapers etc. are used for leveling and markers are used for layout of seedbed. Type D. Seed bed preparation. It refers to a very shallow operation intended to prepare a seed bed or make the soil to suit for planting. Weed control and structural development of the soil are the objectives. Point B. Intercultivation, intertillage. The tillage operations that are carried out in the standing crop after the sowing or planting and prior to the harvesting of the crop plants are called intertillage. This is also called as intercultivation or post-seeding planting cultivation. It includes harrowing, hoeing, weeding, earthing up, drilling or side dressing of fertilizers etc. Spade, hoe, weeders etc. are used for intercultivation. Intertillage helps to incorporate top-dressed manures and fertilizers to earth up and to prune roots. Type 2. Off-season tillage. It is done during fallow or non-cropped season, summer. Tillage operations done for conditioning the soil suitably for the forthcoming main season crop are called off-season tillage. Off-season tillage may be post-harvest tillage, summer tillage, winter tillage and fallow tillage. Special purpose tillage. Tillage operations intended to serve special purposes are said to be special purpose tillage. They are: Point A. Subsoiling. To break the hard pan beneath the plough layer, special tillage operation, chiseling, is performed to reduce compaction. Subsoiling is essential and once in 4 to 5 years where heavy machineries are used for field operations, seeding, harvesting and transporting. Advantages of subsoiling are: greater volume of soil may be obtained for cultivation of crops, excess water may percolate downward to recharge the permanent water table, reduce runoff and soil erosion, and roots of crop plants can penetrate deeper to extract moisture from the water table. Point B. Clean tillage. It refers to working of the soil of the entire field in such a way no living plant is left undisturbed. It is practiced to control weeds, soil-borne pathogen and pests. Point C. Blind tillage. It refers to tillage done after seeding or planting the crop in a sterile soil, either at the pre-emergence stage of the crop plants or while they are in the early stages of growth so that crop plants, sugarcane, potato etc. do not get damaged, but extra plants and broad-leaved weeds are uprooted. Point D. Dry tillage. Dry tillage is practiced for crops that are sown or planted in dry land condition having sufficient moisture for germination of seeds. This is suitable for crops like broadcasted rice, jute, wheat, all seed crops, pulses, potato and vegetable crops. Dry tillage is done in a soil having sufficient moisture, 21 to 23%. The soil becomes more porous and soft due to dry tillage. Besides, the water holding capacity of the soil and aeration are increased. These conditions are more favorable for soil microorganisms. Point E. Wet tillage or puddling. The tillage operation that is done in a land with standing water is called wet tillage or puddling. Puddling operation consists of plowing repeatedly in standing water until the soil becomes soft and muddy. Puddling creates an impervious layer below the surface to reduce deep percolation losses of water and to provide soft seed bed for planting rice. Puddling is done in both the directions for the incorporation of green manures and weeds. Wet tillage destroys the soil structure and the soil particles that are separated during puddling settle water. Wet tillage is the only means of land preparation for transplanting semi-aquatic crop plants such as rice. Planting after wet tillage makes the soil level and compact. Puddling hastens transplanting operation as well as establishment of seedlings. Wet land plows are normally used for wet tillage. Point F. Stubble or post-harvest tillage. Tillage operation carried out immediately after harvest of crop to clear off the weeds and crop residues and to restore the soil structure. Removing of stiff stubbles of sugarcane crop by turning and incorporating the trashes and weeds, thus making the soil ready to store rain water etc., are the major objectives of such tillage operations. Point G. Summer tillage. Operation being done during summer season in tropics to destroy weeds and soil-borne pests and diseases, checking the soil erosion and retaining the rain water through summer showers. It affects the soil aggregates, soil organic matter and sometimes favor wind erosion. Point H. Winter tillage. It is practiced in temperate regions where the winter is severe that makes the field unfit for raising crops. Plowing or harrowing is done in places where soil condition is optimum to destroy weeds and to improve the physical condition of the soil and also to incorporate plant residues. Point I. Fallow tillage. It refers to the leaving of arable land uncropped for a season or seasons for various reasons. Tilled fallow represent an extreme condition of soil disturbance to eliminate all weeds and control soil-borne pest etc. Fallow-tilled soil is prone to erosion by wind and water and subsequently they become degraded and depleted. Depth of plowing. Desirable plowing depth is 12.5 to 20 centimeters. Plowing depth varies with effective root zone depth of the crops. Plowing depth is 10 to 20 centimeters to shallow-rooted crops and 15 to 30 centimeters to deep-rooted crops. Deep plowing is done to control perennial weeds like Cynodon dactylon and to break soil-hard pans. Since deep plowing increases the cost, most farmers resort to shallow plowing only. Number of plowing. It depends on soil conditions, time available for cultivation between two crops, turnover period, type of cropping systems etc. Small or fine seeded crop requires fine tilth, which may require more plowings. Zero tillage is practiced in rice fallow pulse crops or relay cropping system. 3 numbers of puddling is sufficient for rice cultivation. Minimum numbers of plowing are taken up at optimum moisture level to bring favorable tilth depending on the need of the crop and financial resources of the farmer. In fact, this brought the concept of minimal tillage or zero tillage systems. Time of plowing. The time of plowing is decided based on moisture status and type of soil. The optimum moisture content for tillage is 60% of field capacity. Plowing at right moisture content is very important. Summer plowing, March to May, can be practiced utilizing summer showers to control weeds and conserve soil moisture. Light soils can be worked under wide range of moisture. Loamy soils can be easily brought to good tilth. Pulverization of clay soils is difficult as they dry into hard clods. Method of plowing. Plowing aims at stirring and disturbing the top layer of soil uniformly without leaving any unplowed strips of land. Straight and uniformly wide furrows give a neat appearance to the plowed field. When the furrows are not straight or when the adjacent furrows are not uniformly spaced, narrow strips of land are left unplowed. The correct inter-furrow space is little over the width of the furrow slice. After the harvest of a crop, the land is first plowed along the length of the field. This reduces the number of turns at the headlands for opening fresh furrows. The next plowing is done across the field for breaking furrows of the previous plowing. This must increase the turns at the headlands and the empty turns along the headlands, but is unavoidable. New turns are taken 6 meters wide each time till the entire field is covered. Effects of tillage on soil and plant growth. Point A. Effect on soil. Loosens the soil, which favors the germination and growth of crop. Improves the soil structure due to alternate drying and cooling. Improves soil permeability, soil aeration and soil inversion. Facilitates the movement of water in soil. Results in soil and water conservation through higher infiltration, reduce runoff and increase depth of soil for moisture storage. Holds more water in the soil. Increased soil aeration helps in multiplication of microorganisms. Organic matter decomposition is hastened, resulting in higher nutrient availability. Increased aeration helps in degradation of herbicide and pesticide residues and harmful allelopathic chemicals exuded by roots of previous crops or weeds. Tillage operations also influence the physical properties of soil like pore space. Tillage increase the pore spaces, that is space between the soil particles, due to equal amount of capillary and non-capillary, macro and microspores, pores. This facilitates free movement of air and moisture in the soil and increases infiltration. Soil structure. Soil with crumbly and granular clods are considered as soil with good structure, which can be achieved by proper tillage operations at optimum moisture. This reduces the soil loss due to erosion. Bulk density. When soil is loosened, the soil volume increases without any effect on weight. Therefore, bulk density of tilled soil is less than untilled soil, which is favorable in many ways for crop, microorganisms, etc. Soil color. Tillage increases oxidation and decomposition, resulting in fading of color. The organic matter is mainly responsible for the dark brown to dark gray color of soil. Soil water. Tillage improves soil water in different ways, which depends on soil porosity, soil depth and roughness. Also increases rate of infiltration, water holding capacity, WHC, and hydraulic conductivity. Soil temperature. Tillage creates up to soil temperature for seed germination and seed establishment. Tillage loosens the soil surface, resulting in decrease of thermal conductivity, rate of heat transfer at which the heat penetrates, and heat capacity, heat storage unit area. Point B. Effects on crop growth. Tillage loosens the soil, thereby favors the germination and establishment of seeding. Tillage helps in maintaining the optimum plant stand. Increases depth of root penetration. Roots proliferate profusely in loose soil and increase the growth of seminal and lateral roots. Reduce the competition within crop and weeds for light, water, nutrients and space, thereby helps in better growth of crop. Tillage reduce the pest attack on succeeding crop. Tillage helps in availability of nutrients to crop in proper amount. Factors affecting intensity and depth of the tillage operations. Several factors are responsible for deciding intensity and depth of tillage operations. They are soil type, crop and variety, type of farming, moisture status of the soil, climate and season, extent of weed infestation, irrigation methods, special needs and economic condition, and knowledge and experience of the farmer. Number 1. Crop. The crop to be grown decides the type and preparatory tillage given to the land. Hardy crops like sorghum and other millets are not sensitive about tilth. Production of fine tilth will increase the cost of cultivation, which is not economic. Small seeded or delicate crops like tobacco, chili, coriander, sesame, mustard, etc. require a fine seed bed for which land is repeatedly cultivated to get required fine tilth. Sugarcane and other root crops require deep cultivation of land to lose the soil to the required depth. Root or tuber crops require deep tillage, whereas rice requires shallow puddling. Number 2. Soil type. A clay soil is amenable to cultivation only within a narrow range of moisture. Outside this range, the soil can't be worked satisfactorily and increases the draft required. Too wet or too dry soils are difficult to cultivate. The lighter soils can be worked under a wide range of moisture, and the drought required for their manipulation is much less. Loamy soils are easily brought to good tilt with little cultivation and expenditure of energy. Number 3. Climate. It influences the moisture in the soil, the drought required for cultivation, and depth and types of cultivation done. For example, in scarcity areas the rainfall is low and the moisture in the soil prior to sowing does not ordinarily permit deep cultivation, which tends to dry up soil to a greater depth and reduce moisture available to the crops eventually. Finally, sowings cannot be done till depth of cultivated soil is properly moistened. This results in delayed sowing and consequently the effect on growth and yield of crop. Deep cultivation is beneficial in regions having better rainfall, particularly temperate regions, for promoting aeration. Summer showers are received in South India, which favors moist condition and ultimately beneficial for preparing the land for next season crops. Number 4. Type of farming. It influences the intensity of land preparation. There are two types: irrigated and dry land rain farming. Under irrigated farming, intensive farming is followed, which includes cultivation of more than two crops in a year continuously without much interval between them. During this narrow period of interval, the land is to be cultivated repeatedly to bring required title without subjecting the soil for natural weathering for a long period. The frequency and extent of tillage operations increase the cost of cultivation, which serious as the profitable crops is raised in an intensive manner. Dry land farming depends entirely on rains, and in such areas only one crop is taken in a year. The interval between crops and successive cultivation operations is long. Weathering plays an important role than cultivation. Hence, they are limited with wide intervals between them. The cost of cultivation is kept down, and the low productivity of land does not warrant a higher investment. Number 5. Cropping system. Involves different crops, which need different types of tillage. Crop following rice needs repeated preparatory tillage for obtaining an ideal seedbed. Crops following tuber crops like potato require minimum tillage. Similarly, crops following pulses need lesser tillage than that of following sorghum, maize or sugarcane. Tillage implements and their works. Point A. Chisel plow, subsoil breaking. Point B. Rotary plow, cut and pulverize the light soil. Point C. Ridge plow, earthling up and form ridges and furrows. Point D. Basin luster, prevent runoff and form basins. Point E. Disc plow, deep plowing in grassed field. Point F. Tractor-drawn cultivator, destroy weeds and breaking clods. Point G. Sweep cultivator, harvesting groundnut and used in stubble mulching. Point H. Harrows, preparation of seedbed, destroy weeds. Point I. Planka micro-leveling. Point J. Star weeder, weeding in dry lands and groundnut. Point K. Potato digger, used to harvest potatoes. Point L. Groundnut digger, used to harvest groundnut. Point M. Groundnut sheller, used to separate kernels from the pods. Point N. Maj sheller, used to separate maj grains from cobs. Point O. Seed dressing drum, used to treat the seed with chemicals. Point P. Hand gin, used to separate lint from seed cotton. Tillage implements. Any device used to carry on some work is called as implement. Implements are operated by animal power or by machinery. Implements are classified into primary, secondary, and intercultural depending on the purpose for which it is being used. Implements for primary tillage. Plow. Plowing is the primary tillage operations, which are performed to cut, break, and invert the soil partially or completely. Plowing essentially means opening the upper crust of the soil, breaking the clods, and making the soil suitable for sowing seeds. Country or indigenous plow. It penetrates into the soil and breaks it and open. The functional components include share, body, shoe, handle, and beam. Figure 2.1. It can be used for dry land, garden land, and wetland plowing operations. Share. It is the working part of the plow attached to the shoe with which it penetrates into the soil and breaks it open. Shoe. It supports and stabilizes the plow at the required depth. Body. It is main part of the plow to which the shoe, beam, and handle are generally attached. In country plow, body and shoe are integral part. Beam. It is generally a long wooden piece, which connects the main body of the plow to the yoke. Handle. A wooden piece vertically attached to the body to enable the operator to control the plow. Operational adjustments. Point A. Lowering or raising the beam with respect to the plow body, resulting in a change in the angle of the share with the horizontal plane to increase or decrease the depth of operation. Point B. Changing the length of the beam, body to yoke on the beam, to increase or decrease the depth of operation. Point C. The size of the plow is represented by the width of the body. Mold board plow. Functions. To cutting the furrow slice, to lifting the soil, to turning the furrow slice, and to pulverizing the soil. Components. MB plow consists of Figure 2.2, share, mold board, land side, frog and tail piece. Share. It penetrates into the soil and makes a horizontal cut below the soil surface. It is a sharp, well-polished and pointed component. The shares are made of chilled cast iron or steel. The steel mainly contains about 0.70 to 0.80% carbon and about 0.50 to 0.80% manganese besides other minor elements. Mold board. The mold board is that part of the plow which receives the furrow slice from the share. It lifts, turns and breaks the furrow slice. To suit different soil conditions and crop requirements, mold board has been designed in different shapes. The mold board is of following types: A. General purpose; B. Stubble; C. Sod or breaker; and D. Slat. Point A. General purpose. It is a mold board having median curvature lying between stubble and sod. The sloping of the surface is gradual. It turns the well-defined furrow slice and pulverizes the soil thoroughly. It has a fairly long mold board with a gradual twist, the surface being slightly convex. Point B. Stubble type. It is short but broader mold board with a relatively abrupt curvature which lifts, breaks and turns the furrow slice used in stubble soils. Its curvature is not gradual but it is abrupt along the top edge. This causes the furrow slice to be thrown off quickly, pulverizing it much better than other types of mold board. This is best suited to work in stubble soil that is under cultivation for years together. Stubble soil is that soil in which stubble of the plants from the previous crop is still left on the land at the time of plowing. Point C. Sod or breaker type. It is a long mold board with gentle curvature which lifts and inverts the unbroken furrow slice. It is used in tough soil of grasses. It turns over thickly covered soil. This is very useful where complete inversion of soil is required by the farmer. Point D. Slat type. It is a mold board whose surface is made of slats placed along the length of the mold board, so that there are gaps between the slats. This type of mold board is often used where the soil is sticky because the solid mold board does not scour well in sticky soils. Land side, it is the flat plate which bears against and transmits lateral thrust of the plough bottom to the furrow wall. It helps to resist the side pressure exerted by the furrow slice on the mold board. It also helps in stabilizing the plough while it is in operations. Frog is that part of the plough bottom to which the other components of the plough bottom are attached. It is an irregular piece of metal. It may be made of cast iron for cast iron ploughs, or it may be welded steel for steel ploughs. Tailpiece, it is an important extension of mold board which helps in turning a furrow slice. Plough accessories. There are a few accessories necessary for plough such as 1. Jointer, 2. Coulter, 3. Gauge wheel, 4. Land wheel and 5. Furrow wheel. Jointer, it is a small irregular piece of metal having a shape similar to an ordinary plough bottom. It looks like a miniature plough. Its purpose is to turn over a small ribbon-like furrow slice directly in front of the main plough bottom. This small furrow slice is cut from the left and upper side of the main furrow slice and is inverted so that all trashes on the top of the soil are completely turned down and buried under the right-hand corner of the furrow. Coulter, it is a device used to cut the furrow slice vertically from the land ahead of the plough bottom. It cuts the furrow slice from the land and leaves a clear wall. It also cuts trashes which are covered under the soil by the plough. The coulter may be A. Rolling type disc coulter or B. Sliding type knife coulter. Gauge wheel, it is an auxiliary wheel of an implement to maintain uniform depth of working. Gauge wheel helps to maintain uniformity in respect of depth of ploughing in different soil conditions. It is usually placed in hanging position. Land wheel, it is the wheel of the plough, which runs on the ploughed land. Front furrow wheel, it is the front wheel of the plough, which runs in the furrow. Rear furrow wheel, it is the rear wheel of the plough, which runs in the furrow. Adjustment of mold board plough. Vertical suction. Vertical clearance, it is the maximum clearance under the land side and the horizontal surface when the plough is resting on a horizontal surface in the working position. It is the vertical distance from the ground, measured at the joining point of shear and land side. Figure 2.4. It helps the plough to penetrate into the soil to a proper depth. This clearance varies according to the size of the plough. Horizontal suction. Horizontal clearance. It is the maximum clearance between the land side and a horizontal plant touching point of shear at its gunnel side and heel of land side, figure 2.4. This suction helps the plough to cut the proper width of furrow slice. This clearance varies according to the size of the plough. It is also known as side clearance. Throat clearance, it is the perpendicular distance between point of shear and lower position of the beam of the plough. Plough size, the size of the mold board plough is expressed by width of cut of the soil. Disc plough. It is a plough which cuts, turns and in some cases breaks furrow slices by means of separately mounted large steel discs. A disc plough is designed with a view of reduce friction by making a rolling plough bottom instead of sliding plough bottom. A disc plough works well in the conditions where mold board plough does not work satisfactorily. Advantages of disc plough. A disc plough can be forced to penetrate into the soil which is too hard and dry for working with a mold board plough. It works well in sticky soil in which a mold board plough does not scour. It is more useful for deep ploughing. It can be used safely in stony and stumpy soil without much danger of breakage. A disc plow works well even after a considerable part of the disc is worn off in abrasive soil. It works in loose soil also, such as peat, without much clogging. Disadvantages of disc plow. It is not suitable for covering surface trash and weeds as effectively as moldboard plow does. Comparatively, the disc plow leaves the soil in rough and more cloddy condition than that of moldboard plow. Disc plow is much heavier than moldboard plow for equal capacities because penetration of this plow is affected largely by its weight rather than suction. There is one significant difference between moldboard plow and disc plow, that is, moldboard plow is forced into the ground by the suction of the plow, while the disc plow is forced into the ground by its own weight. Types of disc plow. Disc plows are of two types: 1. Standard disc plow and 2. Vertical disc plow. Standard disc plow. It consists of steel disc of 60 to 90 centimeters diameter, set at a certain angle to the direction of travel. Each disc revolves on a stub axle in a thrust bearing, carried at the lower end of a strong stand which is bolted to the plow beam. The angle of the disc to the vertical and to the furrow wall is adjustable. In action, the disc cuts the soil, breaks it and pushes it sideways. There is little inversion of furrow slice as well as little burying of weeds and trashes. The disc plow may be mounted type or trailed type. In mounted disc plow, the side thrust is taken by the wheels of the tractor. Disc is made of heat-treated steel of 5 mm to 10 mm thickness. The amount of concavity varies with the diameter of the disc. The approximate values being 8 cm for 60 cm diameter disc and 16 cm for 95 cm diameter. A few important terms connected with disc plow is explained below. Disc: it is a circular, concave revolving steel plate used for cutting and inverting the soil. Disc angle: it is the angle at which the plane of the cutting edge of the disc is inclined to the direction of travel. Usually the disc angle of good plow varies between 42 degree to 45 degree. Tilt angle: it is the angle at which the plane of the cutting edge of the disc is inclined to a vertical line. The tilt angle varies from 15 degree to 25 degree for a good plow. Scraper: it is a device to remove soil that tends to stick to the working surface of a disc. Concavity: it is the depth measured at the center of the disc by placing its concave side on a flat surface. Vertical disc plow: it is the plow which combines the principle of regular disc plow and disc harrow and is used for shallow working in the soil. Draft of disc plow: the disc plow is lighter in draft than the moldboard plow, turning same volume of soil in similar conditions. In very hard soil, some extra weight is added to the wheel which increases the draft. Rotary tiller: the rotary cultivator is widely considered to be the most important tool as it provides fine degree of pulverization, enabling the necessary rapid and intimate mixing of soil besides reduction in traction demanded by the tractor driving wheels due to the ability of the soil working blades to provide some forward thrust to the cultivating outfit. Rotary tiller is directly mounted to the tractor with the help of 3-point linkage. The power is transmitted from the tractor PTO, power takeoff, shaft to a bevel gearbox mounted on the top of the unit, through telescopic shaft and universal joint. From the bevel gearbox the drive is further transmitted to a power shaft, chain and sprocket transmission system to the rotor. The tines are fixed to the rotor and the rotor with tines revolves in the same direction as the tractor wheels. The number of tines varies from 28 to 54. A leveling board is attached to the rear side of the unit for leveling the tilled soil. A depth control lever with depth wheel provided on either side of the unit ensures proper depth control. The following types of blades are used with the rotor: L-type blade works well in trashy conditions. They are more effective in cutting weeds and they do not pulverize the soil much. Twisted blade suitable for deep tillage in relatively clean ground, but clogging and wrapping of trashes on the tines and shafts. Straight blade employed on mulches designed mainly for secondary tillage. Chisel plow. Chisel plows are used to break through and shatter compacted or otherwise impermeable soil layers. Deep tillage shatters compacted subsoil layers and aids in better infiltration and storage of rainwater in the crop root zone. The improved soil structure also results in better development of root system and the yield of crops and their drought tolerance is also improved. The functional component of the unit include reversible shear, tine, chisel, beam, cross shaft and top link connection. Subsoil plow. The function of the subsoiler is to penetrate deeper than the conventional cultivation machinery and break up the layers of the soil, which have become compacted due to the movement of heavy machinery or as a result of continuous plowing at a constant depth. These compacted areas prevent the natural drainage of the soil and also inhibit the passage of air and nutrients through the soil structure. The subsoiler consists of heavier tine than the chisel plow to break through impervious layer, shattering the subsoil to a depth of 45 to 75 centimeters and requires 60 to 100 horsepower to operate it. The advantages are same as that of chisel plow. Plowing system. Normal plowing, it is the plowing up to a depth of about 15 centimeters. Contour plowing, it is the method of plowing in which the soil broken and turned along the contours. Plowing of land. The plowing of land separates the top layer of soil into furrow slices. The furrows are turned sideways and inverted to a varying degree, depending upon the type of plow being used. It is a primary tillage operation, which is performed to shatter soil uniformly with partial or complete soil inversion. There are a few important terms frequently used in connection with plowing of land. Furrow, it is a trench formed by an implement in the soil during the field operation, figure 2.7a. Furrow slice, the mass of soil cut, lifted and thrown to one side is called furrow slice. Furrow wall, it is an undisturbed soil surface by the side of a furrow. Crown, the top portion of the turned furrow slice is called crown. Back furrow, a raised ridge left at the center of the strip of land when plowing is started from center to side is called back furrow. When the plowing is started in the middle of a field, furrow is collected across the field and while returning trip another furrow slice is lapped over the first furrow. This is the raised ridge which is named as back furrow, figure 2.7b. Dead furrow, an open trench left in between two adjacent strips of land after finishing the plowing is called dead furrow, figure 2.7c. Headland, while plowing with a tractor to turn, a strip of unplowed land is left at each end of the field for the tractor to turn, that is called headland. At the end of each trop, the plow is lifted until the tractor and the plow have turned and are in position to start the return trip. The headland is about 6 meters for 2 or 3 bottom tractor plow and 1 meter more for each additional furrow. Methods of plowing. In order to provide furrows at all times on the right-hand side of the plow, two method of working are used: A. Gathering, B. Casting. Point A. Gathering. Whenever a plow works round a strip of plowed land, it is said to be gathering. Point B. Casting. Whenever a plow works round a strip of unplowed land, it is said to be casting. Plowing of a field by casting or gathering alone is normally uneconomical. The following are a few important methods used in tractor plowing. 1. Continuous plowing method and 2. Round and round plowing.
We politely request, please like, share and subscribe our channel Sri Raj Lakshmi Publication.